the strange link between our Earth's moon and the first nuclear test. Despite being one of the two perpetual occupants of Earth's skies, the moon still remains somewhat of a mystery to us feeble-minded Earthlings. Scientists and astronomers still debate about the unknown origins of Earth's satellite, with the most popular theory being the giant impact hypothesis. In other words, the moon was created by something impacting our Earth, and part of the Earth flew out and became our moon. This theory speculates that some massive object slammed into our Earth at some point in distant cosmic history. Pieces of the smashed object and the hunks of Earth which it tore loose were all pulled together by their own gravity and over time formed our own moon, or so the giant impact thinking goes. That's just a theory, of course. One problem with this theory is the fact that analysis of the moon's various soil and rock samples show very little evidence of so-called volatiles, or organic compounds or elements such as zinc or water, which evaporate easily. These are highly abundant in most places on Earth, but not on the moon. If the moon were to have its origin in a giant impact, many of these volatiles, or at the very least their chemical traces, should have been found on the moon in similar concentrations. To help resolve this hole in the giant impact theory of the moon's creation, a team of chemists and geologists from the University of California, San Diego, decided to look for similar evidence in a much more recent event, that is, the 1945 Trinity nuclear test. The researchers guessed that conditions in a nuclear blast in the desert might simulate conditions similar to those of a giant cosmic impact, so they began analyzing the composition of trinitite, a green radioactive glass formed by the Trinity test. Their analysis found that trinitite samples, like lunar soil, are curiously devoid of any volatile compounds. High-temperature evaporation, such as those caused by a nuclear blast or a hypothetical cosmic collision, could explain the absence of certain volatile chemicals or elements. And according to UC San Diego professor and head of the study James Day, this likely indicates that a giant impact hypothesis could actually have scientific validity, at least on a chemical level. He said it has been conventional wisdom, but now we have experimental evidence to show it. Their data and results have been published in Science Advances, and if the data holds up further scrutiny, it could mean a complete reconception of the moon. If it is proven that the moon used to be part of the Earth, it might explain the strange and unexplained connections so many living things seem to share with our closest cosmic neighbor. This is by Brett Tingley, Mysterious Universe Unbended Reality. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. And according to the article on New Scientist by Leah Crane, the glass from nuclear test site shows the moon was born dry. So we can recreate the giant impact that led to the moon's formation in a lab, but humans have made some other big explosions, and by examining residue from the first detonation of a nuclear weapon, researchers cracked a window into the moon's past. On July 16, 1945, the U.S. Army detonated nuclear weapons for the first time in an operation codenamed Trinity, and as this exploded with energy equivalent to 20 kilotons of TNT, the sand underneath it melted and produced a thin sheet of mostly green glass, and they dubbed this trinitite because it was a Trinity explosion. Now, the explosion brought the area around the explosion here to temperatures of over 8,000 degrees centigrade and pressures nearing 80,000 atmospheres. So these extreme conditions are similar to those created as the moon formed in a colossal collision between Earth and another rock, probably about the size of Mars. James Day at the Scripps Institute of Oceanography in California says, "It is as close as we can probably get to conditions that you might envision on a planetary body in the early solar system. Fortunately for planetary science, scientists meticulously measured and recorded the details of this detonation, the Trinity detonation, so there is plenty of information to work with. Day and his colleagues took advantage of the past precision to investigate why the moon has surprisingly little water and other volatiles with a relatively low boiling point, much less than Earth. To do so, they studied the distribution of one volatile element, and that is zinc, in trinitite, collected at different distances out from the explosion center. They found that the closer to the explosion the trinitite formed, the less zinc it had, especially when it came to zinc's lighter isotopes. That's because these evaporated in the intense heat of the explosion, while the heavier isotopes did not, and so remained in the trinitite. The ratios of different forms of zinc left behind in trinitite showed remarkable parallels to what was observed in the moon rocks retrieved in the Apollo missions. Isn't that something? A dry moon. Day says what's critical here is that the fractionation factors, how the heavy and light isotopes separate from each other, exactly match with that on the moon. This means that zinc and other volatile elements, most notably water, probably evaporated off the moon while it was being formed in a volatile explosion, collision, or soon afterwards, while its surface was still incredibly hot. Previously, glass deposits from the moon with unusually high amounts of volatiles had led scientists to suspect that the moon's interior might have lots of water, similar to Earth's mantle. This study cast doubt on that idea. If water evaporated along with other volatiles as the moon was being formed, it's hard to imagine how much more could have lingered under the surface. Patrick McGovern, the Lunar and Planetary Institute in Texas, says, "I think it's a pretty neat use of some of the data that we have on the ground here on Earth to address a planetary problem." This was from Science Advances. So in conclusion, this is a very exact evidence showing that the moon is dry of water, and something happened that was close to what we would call a nuclear explosion, drying up everything on the moon. And they don't believe there's water under the surface of the moon either. Please leave your comments, and thank you for your support.